Good morning. This lesson is for my Integrated 1 class. This is a Unit 3 review for the test that we're going to be taking on Thursday and Friday this week. But before I get started, I want to say that I hope everyone is doing okay out there. So let's go ahead and jump into our goals. We have 4 goals today, just to review everything we've discussed. Our first goal is to review a relation and how to represent them. Our second goal is to review domain and range. Our third goal is to review functions. And our fourth goal is to review creating repeating numbers and writing equations. Okay, so we have 4 goals. Let's go ahead and jump right into our first goal. A relation is an input that makes an output, and we have 5 ways to represent relations. Right, so inputs are making outputs, that's relation, that's basically it. So we have 5 ways. I can write them as ordered pairs, as a table, as a function notation. I can graph them, or I can write them as a mapping diagram. So here, if I plug in 2, that's my input, I get 3 as an output. Here, if I plug in 5, I get 7 as an output. So this is what it looks like as an ordered pair. And remember, they're called ordered pairs because they're ordered like the alphabet, right? So it's an X value and a Y value, right? Ordered pairs. I can rewrite these ordered pairs as a table. Plug in 2, I get 3. Plug in 5, I get 7. So I can turn ordered pairs into a table, or I can turn a table into ordered pairs. The next way that I can write my relation is what we call function notation. So I can say f of 2 is equal to 3, or f of 5 is equal to 7. I plug in 2, I get 3. I plug in 5, I get 7. I should be able to rewrite this as a table, or as ordered pairs, or take ordered pairs and write it in function notation, or as a table. We have to be able to bounce from one to the other. Graphically, my x value is 2, my y value is 3. Right, so there's my ordered pair 2, 3, or I can write it in function notation or as a table. Here's my ordered pair 5, 7, so I went over 5 on the x, up 7 on the y, so there's 5, 7. So I can represent a relation as a graph. Plug in 5, get 7, plug in 2, get 3. I can also represent it as a mapping diagram. Here are all my x values, here are all my y values, or f of x values. So 2 maps to 3. 5 maps to 7, or if I plug in 2, I get 3, I plug in 5, I get 7. These are the 5 ways that I can represent a relation. Okay, so I'm going to go ahead and check off this goal. You're going to need, on this test, to bounce between different versions. So if I gave you this version, then you could turn it into a table, right, and go from there. Our second goal is to review domain and range. Domain is all the inputs, range is all the outputs. So the domain for my my example right here, I would say domain. And then you would put braces. So all my inputs, those are the x values. So my inputs would be 2 and 5, you see? 2 and 5, 2 and 5, 2 and 5, 2 and 5. So all the x values are my domain, right? All the inputs. So my domain is 2 and 5. My range is going to be all the outputs, all the y values. So that would be 3 and 7, 3 and 7, 3 and 7, 3 and 7, 3 and 7. So the range is 3 and 7. Okay, so this is part 1 of the video. I'll be back to talk about part 2. I'm back. All right, so let's move on to our third goal here, and that's reviewing functions. And you know, let me check off our second goal because we did review domain and range. Let's review functions. A function is a relation where each input has exactly one output. I have 2 examples on the board, and the question I'm asking for each example is it a function or no? And so let's see here. The input 2 goes to 3, the input 4 goes to 1, and the input 5 goes to 1. Each input has exactly one output. Now, I didn't say that each input can't go to the same output, but yes, this is a function. Yes, this is a function. And so let's just take some time to look at this in other forms. So as a table, it looks like this. 2, 3, 4, 1. And 5, 1. No repeating in the x. Let's look at this as a in function notation. f of 2 makes 3, f of 4 makes 1, and f of 5 makes 1. Again, no repeating in the x's. Let's look at this as a mapping diagram. So I have 2, 4, 5 are my x values. And I don't need to write repeating y values, so I'm just going to write 3 and 1. 2 goes to 3, 4 goes to 1, and 5 goes to 1. Again, this is what a function will look like in a mapping diagram. Notice there's not multiple arrows coming from a 5 or a 4 or from a 2. So this is what a function will look like. And then our last way that we would consider a function is on the graph. So 2, 3, so I go over 2 and I go up 3. I go over 4, I go up 1. I go over 5 and I go up 1. Again, I can't draw a vertical line through more than one point, so this is a function. So that's what a relation as a function would look like. So let's move on to now example 2. And before I finish example 2, I want to make sure that everything's on the whiteboard here. Okay, yeah, I'm good. All right. So again, a function is a relation where each input has exactly one output. Input 3 makes output 2, input 4 makes output 1, input 3 makes output 0. This is not a function. And it's not a function because 3 has multiple outputs. All right, and let's look at what this looks like in its other forms. So we see that I have multiple 3's in the x value. That means it's not a function. As an ordered pair, it would be 3, 2, 4, 1. We gotta put a line between 4, 1, and 3, 0. Notice again that I have the same x, so that means that it's not a function. The x is repeating, not a function. In function notation, f of 3 goes to 2, f of 4 goes to 1, and again here I have the repeating x, and that goes to 0. Repeating x's tell me that it's not a function. If I write this as a mapping diagram, there's my x, and here's my f of x. Again, I don't need to write repeating, so it would be 3 and 4, and my f of x would be 2, 1, 0. So 3 goes to 2, 4 goes to 1, and then 3 also goes to 0. Notice there's multiple arrows coming out of the 3. That tells me I do not have a function. And finally, graphically, and I'm sorry I'm writing this a little bit jumbled, but I'm trying to be as efficient as possible. So I go over 3, and I go up 2. I go over 4, I go up 1. And I go over 3 and I go up 0. Notice they're vertically. These are vertical to each other. If I can draw a line through, if I can draw a line through multiple points, it's not a function. So I'm going to check off goal 3, and then I'm going to go ahead and talk about goal 4. I just need to erase the board, and I'll be back. I'm back. All right, so here we go. I'm going to talk about our 4th goal. That's reviewing, creating, and repeating numbers and writing equations. So the key idea here is I need to use this formula. That's the first y value plus a common difference times parentheses x value of that row plus the opposite of the first x value. If we follow this, we should be able to do a majority of this 4th goal. So I'm going to rewrite this table with repeating numbers. I'm going to write an equation that represents the table. I'm going to simplify it, I'm going to verify it. So let's just go ahead and jump right in. First thing I need to do is I need to figure out how my y values are changing, and they're changing by subtracting 8. And since every row is changing by subtracting 8, I've found my common difference. It's minus 8. So what I'm going to do now is I'm going to write my table with the repeating numbers, the repeating number pattern. And my first row is going to be 118, so it always stays the same. Remember, the first row always stays the same. Okay, and here we go. So I'm just going to follow this down. So my second row here is my first y value. My first y value is 18. Plus my common difference. So my common difference is minus 8, so I'm going to go minus 8. And I'm going to go parentheses. The x value of this row is 2. And the opposite of the first x value is plus 1, so its opposite is minus 1. Okay, and I have these numbers repeating. So again, I want to write the table with repeating numbers. Again, here for my third row, it's going to be my first y value plus my common difference, which is minus 8, parentheses. X value of that row is 3. Minus 1, because minus 1 is the opposite of my first x value. All right, let's do this for this last row. Here we go. So 4. So again, it's first y value, which is 18, plus my common difference, so it's minus 8, parentheses. The x value of this row is 4, and the opposite of my first x value is minus 1. All right, so I've got repeating numbers, and all the other numbers stay the same through. So this is good enough to generalize this now, which means I replace numbers with the x, or the repeating numbers with the x, and this becomes x here. So again, it's my first y value plus the common difference, and then it's the x value of that row, which is x, plus the opposite of the first x value, so it's minus 1. And from here, I can very quickly write my equation. And my equation, all I have to do is set this equal to f of x, and my equation becomes f of x is equal to 18 minus 8, parentheses, x minus 1. Okay, so let's see here. I wrote the table with repeating numbers, I wrote the equation, and now I'm going to simplify it. And all I have to do to simplify it is distribute. And I get 18 minus 8x minus 8. I'm going to combine like terms. And I get f of x equals minus 8x. Don't lose that negative. Plus 10. All right, I'm going to check the fourth row here. Oh, excuse me. I simplified the equation. And so now I'm going to verify the equation, and I'll plug in 4. And I should get negative 6. Okay. But I'm not going to get negative 6. What did I do wrong? Ah, my mistake was right here. Minus 8 times minus 1, that's plus 8. And then 18 plus 8, that's actually 26. Okay, I made a mistake. I realized that I did this through my head, and I realized I was not going to get the correct number. So now, okay, so you see that minus 8 times minus 1, that should be plus 8. That changes that number. All right, so if I plug in 4, I should get negative 6. So this becomes negative 8 times 4 plus 26. Negative 8 times 4, that's negative 32, plus 26. That's going to give me a negative 6. I got negative 6, so that means I have a good equation. This finishes the Unit 3 review. Hopefully this makes sense to you guys. I'll see you guys later. Bye-bye.